What if one of the most distant planets in our solar system isn't what we think it is? Far beyond the blazing light of the sun, past the swirling clouds of Jupiter and the shimmering rings of Saturn, there lies a world few people ever talk about, a world shrouded in mystery, silence, and deep blue shadows. This is Neptune, the eighth and most distant planet from the sun, a frozen giant, quietly spinning on the edge of our cosmic neighborhood, 30 times farther from the sun than Earth. At that vast distance, sunlight takes more than 4 hours just to reach it. The warmth of the sun that touches our skin is almost non-existent there. Neptune lives in eternal twilight, a place where temperatures can plunge to minus 220 degrees Celsius and the winds howl faster than the speed of sound. Despite being the fourth largest planet in our solar system, Neptune has always been the forgotten giant. While Jupiter's size and storms steal attention and Saturn's rings capture wonder, Neptune remains hidden in the background, cold, mysterious, and often overlooked. Yet beneath that calm, beautiful blue atmosphere lies one of the most unpredictable and violent worlds ever discovered. It's a planet that defies expectations. It shouldn't have the storms it does. It shouldn't be as active as it is. And yet, it's alive with turbulent winds, shifting clouds, and dark, vanishing storms that seem to come from nowhere. Scientists have spent decades trying to understand its behavior, and each new observation only deepens the mystery. Neptune's story isn't just about science, it's about human curiosity. It's about how a planet we once only imagined on paper turned out to be real, strange, and more complex than we ever dreamed. From its mathematical discovery in the 1800s, a planet found not through sight but through logic, to the breathtaking new images from the James Webb Space Telescope, Neptune's history is filled with wonder and shock. And now, after more than a century and a half, humanity is finally beginning to see this distant blue world in a new light. What we're discovering challenges everything we thought we knew, not just about Neptune, but about how planets live, evolve, and survive in the cold, dark corners of space. So before we dive into the newest revelations from NASA and the James Webb Telescope, let's travel back to where it all began, to the story of how Neptune went from an invisible equation on paper to one of the most mysterious worlds in our solar system. The year was the early 1840 seconds a time, when telescopes were crude, astronomy was still young, and the solar system seemed well mapped. Humanity believed it had seen it all. But far beyond the known planets, something strange was happening. Astronomers studying Uranus, the seventh planet, began to notice something they couldn't explain. The planet wasn't following its predicted orbit. It was drifting just slightly, but consistently, as if some unseen hand was pulling on it from the dark. At first, many thought it was an error in calculation or observation, but one young French mathematician, Urbain Le Verrier, refused to dismiss it. Instead, he asked a radical question. What if there's another planet, one we can't see, whose gravity is tugging Uranus off course? Le Verrier spent months performing incredibly complex calculations by hand, analyzing the subtle deviations in Uranus's motion. With only mathematics as his telescope, he predicted where this invisible planet should be, its mass, its orbit, even its distance from the Sun. In September of 1846, German astronomer Johann Galle received Le Verrier's calculations. That very night, he turned his telescope toward the suggested region of the sky. Within a single hour, he saw it, a faint blue dot exactly where the math had said it would be. That dot was Neptune. This was not just a discovery, it was a revolution. For the first time in human history, a planet had been discovered by mathematics before it was ever seen through a telescope. It proved that the laws of physics written by Newton centuries earlier still guided the heavens with perfect precision. It was a moment that shook the foundations of astronomy and confirmed our understanding of how the universe works. But even then, Neptune refused to give up all its secrets. It appeared small, distant, and eerily calm, just a tiny blue orb shimmering in the darkness. Yet scientists immediately realized something was different about it. Its mass was strange. Its orbit didn't fit neatly with the others. And its color, that hypnotic deep blue, hinted at an atmosphere unlike anything we'd seen before. In that moment, Neptune became more than a dot in the night sky. It became a symbol of human intellect and curiosity, proof that the human mind could reach across billions of kilometers of empty space and find a world it could not see. But little did anyone know this was only the beginning. The mysterious new planet that had revealed itself through mathematics would soon reveal a side far more unpredictable and far more violent than anyone expected. After its discovery in 1846, Neptune quickly became the most mysterious planet in the solar system, not just because of how it was found, but because of what it turned out to be. From the very beginning, astronomers were captivated by its deep, hypnotic blue color, a hue unlike any other in the night sky. Through powerful telescopes, Neptune glowed faintly, like a sapphire lost in an endless ocean of darkness. It seemed calm, distant, and quiet, but beneath that peaceful beauty was a storm that defied imagination. Neptune is a world of contradictions, elegant yet violent, cold yet burning with energy. Despite being more than 4.5 billion kilometers away from the Sun, it's a planet alive with movement. While sunlight there is so faint it would look like twilight on Earth, Neptune's atmosphere churns with ferocity, home to the fastest winds ever recorded in the solar system, racing at speeds of up to 2,100 kilometers per hour. That's faster than the speed of sound. Imagine a place where the air itself could tear through steel. Scientists were stunned. How could a planet so far from the Sun, receiving barely any heat or light, generate such violent weather? The answer still puzzles researchers to this day. Some suggest Neptune radiates more energy than it receives, powered by an internal heat source we still don't understand. Others believe complex interactions between methane, hydrogen, and helium in its atmosphere create immense pressure and turbulence. Speaking of methane, it's what gives Neptune its signature blue hue. Methane gas absorbs red light and reflects blue, creating that deep, almost electric shade that makes Neptune look like a frozen ocean suspended in space. But even this beauty hides secrets. Beneath the visible clouds may lie layers of exotic ices, water, ammonia, methane, compressed into strange materials that behave more like metals than liquids. Deeper still could be an ocean of superheated water and gas, thousands of kilometers thick, trapped beneath unimaginable pressure. And then there's the mystery of the Great Dark Spot, Neptune's most iconic feature, first seen by NASA's Voyager 2 spacecraft in 1989. It was a storm roughly the size of Earth, swirling across the planet's southern hemisphere with unimaginable force. But when the Hubble Space Telescope looked again a few years later, it was gone, vanished. And then years after that, another storm just as large appeared in a different location. No one knows why Neptune's storms form or why they disappear so suddenly. Unlike Jupiter's Great Red Spot, which has raged for centuries, Neptune's tempests seem alive, forming, dying, and returning in a strange rhythm, like the heartbeat of a restless world. Beneath the atmosphere lies an interior as strange as its surface. Neptune's magnetic field is tilted dramatically, not aligned with its rotation like Earth's, but twisted and offset, as if something deep inside is broken or misaligned. This skewed magnetism means Neptune's magnetic poles can shift wildly, creating regions of intense radiation and electrical storms that would fry any unprotected spacecraft. Even its moons add to the mystery. The largest, Triton, orbits Neptune backward, a retrograde path that no natural moon of its size should take. Scientists believe Triton was once a dwarf planet, perhaps like Pluto, captured by Neptune's gravity long ago. When it was pulled in, it may have destroyed other moons and reshaped the planet's system forever. Triton is one of the coldest places in the solar system, yet oddly it shows signs of active geysers that shoot nitrogen gas into space, hinting that something alive might be stirring beneath its icy surface. So what really drives Neptune? Why is it so dynamic, so alive, when it should be still and frozen? These questions have haunted astronomers for over a century. Every glimpse we've had from ground-based telescopes to Voyager 2's fleeting flyby has revealed something new and baffling. Neptune refuses to behave like a dead, distant planet. It acts like something more, something that's hiding energy, motion, and mystery deep within. It is a planet that both enchants and unsettles, a world of howling winds, invisible storms, and breathtaking beauty. A giant that lives at the edge of our solar system, wrapped in silence yet filled with fury. And for over a century, it remained largely unseen, forgotten, and unexplored. No spacecraft has returned since Voyager 2. No human eye has looked upon it up close again. But that would change because, decades later, a new telescope would open its golden mirrors to the cosmos and turn toward this distant blue enigma once more. And what it saw would shock scientists around the world. For more than a century after its discovery, Neptune remained nothing more than a faint blue speck in the vast dark ocean of space, a mathematical ghost at the edge of the sun's reach. No human had ever seen it clearly. No spacecraft had ever visited. Then, in the summer of 1989, that changed. After a 12-year journey through the solar system, NASA's Voyager 2, a small nuclear-powered spacecraft launched in 1977, approached Neptune. It had already flown past Jupiter, Saturn, and Uranus, revealing stunning details about each. But now, it was nearing the final frontier, the most distant planet ever visited by humankind. As Voyager 2 drew closer, engineers at NASA's Jet Propulsion Laboratory held their breath. The spacecraft was now 4.3 billion kilometers from Earth, and every signal it sent took over 4 hours to reach us. Any mistake, any malfunction, would mean total silence. But the little probe pressed on, steady and unwavering, racing through the frozen dark toward Neptune, a world that had waited more than a century to be seen. And then, the first images came through. They were breathtaking. Neptune wasn't a dull, lifeless ball of gas. It was alive, brilliant, and violent. The spacecraft's cameras captured a stunning, deep cobalt blue atmosphere streaked with white methane clouds and spinning with massive storms unlike anything ever recorded before. One storm in particular stood out, a dark oval swirling in Neptune's southern hemisphere, larger than the entire Earth. NASA named it the Great Dark Spot. Winds around it screamed at over 2,000 kilometers per hour, the fastest in the entire solar system. It was a planet where storms raged in total darkness, powered not by sunlight but by some mysterious internal heat deep within. But the surprises didn't end there. As Voyager 2 passed behind Neptune, its instruments detected that the planet was hotter than it should be. Something inside Neptune was generating energy, radiating more heat than it received from the Sunday. This discovery shattered expectations. Scientists had assumed the outer planets, so far from sunlight, would be cold, quiet, and dead. But Neptune wasn't. It was alive in a way no one could yet explain. And then there was Triton, Neptune's largest moon. Voyager 2's cameras revealed it in haunting detail. A pale, icy world with strange, dark streaks across its surface. But then something even more astonishing appeared. Plumes, geysers erupting from its surface, shooting nitrogen gas miles into space. That meant Triton was active. It wasn't just a frozen rock, it had energy, motion, and possibly even internal heat. This made Triton one of the most fascinating moons ever studied. Some scientists even speculated it could have subsurface oceans similar to those now suspected beneath the icy crusts of Europa and Enceladus. Voyager 2 also captured Neptune's faint ring system, thin, delicate bands of dust and ice orbiting the planet, nearly invisible until seen through the spacecraft's sensitive cameras. They weren't as grand as Saturn's, but they hinted that Neptune's system had once been far more chaotic, maybe even violent. Perhaps most eerie of all was Neptune's magnetic field. Voyager 2 discovered that it was wildly tilted, not aligned with the planet's rotation, but offset by nearly 47 degrees. It seemed to originate not from the planet's core, like Earth's, but from somewhere deep within its mantle, an impossible, twisted geometry that baffled physicists. For the first time, humanity had come face to face with Neptune, and what it revealed was a paradox. A planet so cold it should be silent, yet filled with unimaginable energy. A world so distant it should be calm, yet roaring with the fastest winds in the solar system. A place of darkness, yet glowing faintly with its own mysterious light. After its historic flyby, Voyager 2 continued onward, leaving Neptune behind, forever carrying with it the final close-up images of the outer planets that humanity would see for decades. No other spacecraft has visited Neptune since. The data it sent back changed our understanding of the outer solar system forever. Neptune wasn't the frozen, lifeless world we had once imagined. It was dynamic, powerful, and unpredictable. A world full of mysteries that even today remain unsolved. For years after Voyager 2's departure, Neptune would return to its silence, orbiting the Sun in solitude, unvisited and almost forgotten. Until more than 3 decades later, a new eye opened in the heavens. The James Webb Space Telescope, with its golden mirrors and incredible sensitivity, would once again turn toward this lonely blue planet, and what it saw next would leave scientists stunned all over again. After Voyager 2's flyby in 1989, Neptune faded back into the quiet darkness of space. For over 3 decades, no spacecraft returned to study it up close. We only had distant telescope observations from Earth and the Hubble Space Telescope, which gave us occasional glimpses of its changing weather and disappearing storms. But for the most part, Neptune remained a mystery, a frozen giant drifting 30 times farther from the Sun than Earth, waiting to be explored again. Astronomers could only watch and wonder. They noticed that Neptune's atmosphere kept changing. Massive storms appeared and vanished. Bright clouds formed and then dissolved, and even its color seemed to shift slightly over time. Yet, with limited data, no one could truly explain what was happening on this faraway world. Then came a new generation of technology, the James Webb Space Telescope, JWST. Launched in 2021, it was the most advanced observatory ever built, capable of seeing an infrared light invisible to human eyes, but perfect for studying cold, distant planets like Neptune. When James Webb turned its golden mirrors toward Neptune for the first time, scientists were stunned. Unlike visible light images, Webb's infrared vision revealed Neptune in a completely new way. The planet didn't appear blue anymore. Instead, it glowed with a ghostly silver tone, showing detailed rings, high-altitude clouds, and strange bright patches near its poles. For the first time in decades, we saw Neptune's entire ring system clearly, along with faint inner moons that had been almost invisible before. Even more intriguing, Webb's data hinted that Neptune's atmosphere might be changing faster than expected. Some regions appeared unusually cold, while others seemed to release heat, suggesting dynamic processes deep inside the planet. These findings reignited scientific curiosity and brought Neptune back into the spotlight. For years, it had been the forgotten giant of our solar system, but with James Webb's help, Neptune became mysterious all over again. Now, scientists believe we're only scratching the surface of what's really happening there, and that future missions could uncover answers that might even reshape how we understand the outer solar system itself. When the James Webb Space Telescope captured its first full images of Neptune, the results shocked astronomers around the world. Everyone expected beautiful, detailed visuals, but no one expected to see Neptune like this. Instead of the familiar deep blue color we see in Hubble images, Neptune appeared as a bright, glowing, silvery orb. Webb's powerful infrared eyes don't detect visible light. Instead, they sense heat energy. What it showed was an incredibly detailed look at Neptune's rings, atmosphere, and temperature, unlike anything seen before. For the first time since Voyager 2's flyby, scientists could clearly see Neptune's thin, icy rings, as well as several of its small inner moons orbiting in perfect harmony. These rings had been nearly invisible for decades, lost in the darkness, and Webb brought them back into view with stunning clarity. But what really caught scientists off guard were the temperature patterns across Neptune's atmosphere. Webb detected that Neptune's southern pole was unusually bright and warm, while the northern regions appeared strangely dim and cold. That shouldn't have been possible. Neptune's seasons last over 40 Earth years, so major temperature changes were expected to be extremely slow. Yet something was clearly happening faster than models predicted. Even more puzzling was the discovery of mysterious bright clouds made of methane ice floating high above Neptune's surface. Some of these clouds reflected so much light that they appeared to shimmer in the data, indicating strong, active weather patterns deep within the planet's atmosphere. It suggested that Neptune's internal heat, possibly generated by its strange core, might still be driving massive storms and updrafts even after billions of years. And then there was Triton, Neptune's largest moon, which unexpectedly stole the spotlight. In Webb's images, Triton outshone Neptune itself. Because its surface is covered in frozen nitrogen that reflects sunlight, it appeared as a bright star-like object next to the planet. Scientists believe Triton's icy crust could be hiding a liquid ocean beneath, heated by tidal forces from Neptune's gravity, a potential habitat for microbial life. These findings reignited interest in Neptune after decades of quiet. Webb's discoveries prove that Neptune is not a dead, frozen world. It's dynamic, evolving, and still full of surprises. Researchers now believe that understanding Neptune could unlock clues about the early formation of our solar system. Since planets like Neptune are similar to many ice giants found around other stars, learning its secrets might also help us understand the most common type of planet in the galaxy. In short, James Webb didn't just take beautiful pictures, it reshaped how we see Neptune. It reminded us that even after centuries of observation, there's still so much we don't know about this mysterious blue world drifting in the farthest reaches of our solar system. Even after the incredible discoveries from the James Webb Telescope, Neptune remains one of the most mysterious worlds in our solar system. Every time we learn something new, more questions appear. Scientists still can't fully explain why Neptune is so active. Despite being one of the coldest planets and far from the Sun, it has the fastest winds ever recorded, over 2,000 kilometers per hour. That means something deep inside Neptune is producing energy we don't yet understand. Its atmosphere also changes in strange ways. Clouds form and vanish within years, and the planet's brightness seems to rise and fall unpredictably. Some scientists think this could be linked to solar activity or internal heat patterns, but no one is sure yet. Neptune's magnetic field is another puzzle. It's tilted and offset, completely unlike Earth's, suggesting the planet's inner structure might be far more complex than we think. And then there's Triton, Neptune's largest moon. It orbits backward, a sign it was likely captured long ago, and shows signs of geysers and possible internal heat hinting at a subsurface ocean. If true, Triton could be one of the most promising places in the outer solar system to search for microbial life. Even Neptune's rings remain mysterious, faint, dark, and constantly changing. They may be leftovers from shattered moons or collisions that happened millions of years ago. So, despite all our progress, Neptune continues to challenge us. It's not just a cold, distant planet, it's a world still full of secrets, waiting for the next mission to uncover what's really happening beneath those deep blue clouds. Even though Neptune sits billions of kilometers away, what we learn from it could reshape how we understand the universe. It's not just a distant ice giant, it's a world that challenges everything we think we know about planet. Neptune's violent storms, mysterious heat, and changing atmosphere prove that even the farthest parts of our solar system are active and alive. Studying it helps scientists understand not only our own planet, but also the many Neptune-like worlds orbiting other stars. And then there's Triton, with its icy geysers and possible underground ocean, a place that might even hold the ingredients for life. From its discovery in the 1800s, to Voyager 2's flyby, and now the James Webb stunning new images, Neptune reminds us that there's still so much left to explore. It stands as proof that even in the coldest, darkest corners of space, there are still wonders waiting to be found. And that's the incredible story of Neptune, the forgotten giant that still guards some of the greatest mysteries in our solar system. If you enjoyed this deep dive into the unknown and want to explore more secrets of space, don't forget to like, subscribe, and turn on the bell icon, because there's so much more waiting beyond the stars. Until next time, keep looking up, because space is always full of surprises.